In 1977, humanity launched two remarkable spacecraft on a journey that no one expected to last for decades. Their mission seemed straightforward: explore the giant planets and then fade into silence. Instead, they transformed our understanding of the solar system forever. As they traveled farther from Earth, every image they returned revealed a universe far more dynamic than scientists had imagined. Familiar worlds became places filled with violent storms, hidden oceans, erupting volcanoes, and mysterious landscapes. These spacecraft were more than machines. They became humanity's eyes in the darkness, carrying our curiosity into regions no explorer had ever reached before. Before their arrival, Jupiter was little more than a striped sphere viewed through telescopes. Saturn's rings appeared smooth and simple. Uranus and Neptune remained distant blue dots with countless unanswered questions. The Voyager missions changed all of that. Close-up observations uncovered incredible complexity, towering storms, delicate ring systems, fractured icy moons, and geological activity where no one expected it. Each discovery forced scientists to rethink long-held ideas about the outer solar system. The opportunity itself was extraordinarily rare. During the late 1970s, the four giant planets aligned in a configuration that occurs only once in roughly 176 years. This allowed a spacecraft to use the gravity of one planet after another like stepping stones, gaining speed without carrying enormous amounts of fuel. NASA recognized the significance of this moment and designed the Voyager mission to take full advantage of this brief cosmic alignment. Voyager 2 launched first in August 1977, followed just weeks later by Voyager 1 on a faster trajectory. Although it launched second, Voyager 1 reached Jupiter first, beginning one of the greatest exploration missions in history. Even in the earliest days of the journey, the spacecraft looked back toward Earth and captured an unforgettable view of our planet and the Moon drifting together in the darkness. A quiet reminder of the tiny world from which this extraordinary voyage had begun. When Voyager 1 arrived at Jupiter in 1979, it revealed a world unlike anything humanity had ever seen. From Earth, Jupiter had always appeared as a distant striped planet, impressive but familiar. Up close, it became a place of relentless motion, where colossal storms twisted through an atmosphere layered with colorful clouds stretching thousands of kilometers across. Every image exposed new details, making the giant planet seem less like a calm sphere and more like a massive engine constantly reshaping itself. The famous Great Red Spot proved to be even more extraordinary than expected. Far larger than Earth, this enormous storm had been raging for centuries, spinning with incredible force while surrounded by countless smaller vortices that constantly formed, collided, and disappeared. Scientists quickly realized that Jupiter's atmosphere was far more turbulent and complex than existing models had predicted. Yet the greatest surprise wasn't Jupiter itself. It was one of its small moons. Before Voyager's visit, Io was thought to be another cold, crater-covered world, silent and inactive like Earth's moon. Instead, the spacecraft captured unmistakable evidence of active volcanoes erupting across its surface. Towering plumes blasted material hundreds of kilometers above the moon, while rivers of molten rock reshaped the landscape. It was the first confirmed discovery of active volcanism beyond Earth, forcing scientists to completely rethink how small worlds could remain geologically alive. Another moon, Europa, presented a very different mystery. Its bright icy surface was crisscrossed by an intricate network of long fractures stretching across the globe. The pattern suggested that the frozen crust might be floating above a vast ocean hidden beneath the ice. Although Voyager couldn't confirm what lay below, the images sparked one of the most exciting scientific questions ever asked. Could an ocean beneath Europa's frozen shell provide conditions suitable for life? Within a single planetary system, Voyager revealed worlds that could not have been more different. One moon erupted with volcanic fire while another hinted at a hidden sea concealed beneath kilometers of ice. In only a matter of weeks, the outer solar system transformed from a collection of distant objects into an extraordinary family of unique worlds, each with its own story. The journey continued toward Saturn, a planet long admired for its graceful appearance. Through telescopes, its rings looked smooth, perfectly shaped, and almost delicate. But as Voyager closed in, that illusion disappeared. The spacecraft revealed an astonishing level of detail that no one had anticipated. Instead of a handful of broad rings, Saturn possessed countless thin ringlets woven together into an intricate structure filled with narrow gaps, twisted patterns, and subtle waves. The entire system appeared alive with motion. New rings were discovered, along with small shepherd moons whose gravity quietly guided and maintained many of the narrow bands. Strange spoke-like markings drifted across portions of the rings, creating patterns that scientists struggled to explain. Saturn's beauty remained undeniable, but it was no longer simple. Every close-up image raised new questions, revealing that the elegant ring system was one of the most complicated structures anywhere in the solar system. Its moons proved equally remarkable. Titan immediately stood out because of its incredibly dense atmosphere, something unique among moons known at the time. Hidden beneath thick layers of haze was a world unlike any other, encouraging scientists to imagine environments that might be dramatically different from Earth's. Enceladus also attracted attention. Although its full story would only emerge years later, Voyager's observations hinted that this icy moon was not entirely dormant. Subtle signs suggested that internal activity might still be shaping its frozen surface. By the time Voyager completed its encounter with Saturn, it had become clear that the giant planets were far more than isolated spheres orbiting the Sun. They were complete systems filled with active moons, dynamic atmospheres, complex chemistry, and mysteries waiting for future generations of explorers to investigate. After completing its historic encounter with Saturn, Voyager 1 was redirected out of the plane of the solar system by the planet's immense gravity. That single maneuver ended its planetary tour but set it on an even more extraordinary journey toward interstellar space. Voyager 2, however, continued alone, becoming the only spacecraft ever to visit Uranus and Neptune. When Voyager 2 arrived at Uranus in 1986, it found a planet unlike anything seen before. Its pale blue appearance suggested a calm and featureless world, yet appearances proved misleading. Uranus rotates on its side, with its axis tilted by nearly 98 degrees, making it one of the most unusual planets in the solar system. Even more surprising was its magnetic field, which was dramatically offset from the planet's center and tilted at a completely different angle than its rotation. This unexpected discovery challenged existing theories about how planetary magnetic fields are formed. The spacecraft also discovered additional rings surrounding Uranus, along with several previously unknown moons. Among them, Miranda became one of the mission's greatest surprises. Its surface looked as though enormous sections had been broken apart and reassembled, creating towering cliffs, deep canyons, and landscapes unlike anything previously observed. Scientists still debate exactly how such a strange world acquired its remarkable appearance. 3 years later, Voyager 2 reached Neptune, the most distant major planet in the solar system. Many expected a cold, quiet world where little ever changed. Instead, Neptune proved astonishingly active. Despite receiving only a small fraction of the sunlight that reaches Earth, its atmosphere generated some of the fastest winds ever measured on any planet. Massive storms raced across its deep blue clouds, including the enormous Great Dark Spot, revealing a surprisingly energetic atmosphere.